Hey, this is Mr. Beckstrom, and today I want to try to find the inverse cosine of the cosine of negative 5 pi over 4. And to do this problem, we first need to know what is the domain of the inverse cosine function. And that is defined as the upper half of the unit circle, specifically defined from 0 to pi. So from 0 to pi. And what I like to do for this is to also give a decimal representation here. So about 0 to 3.14. And I like to do that decimal representation because when I'm using my calculator to check values, I want to make sure that they fall inside there. And I also want to make sure that the angle falls on the upper half of the circle. It's just kind of a double check because I'm going to not only be using coterminal angles, but I'm going to also be reflecting angles across the x-axis occasionally when I have angles that fall on the bottom half of the unit circle. So let's take a look at this first angle here. The first one is negative 5 pi over 4. So if I'm starting at 0 and I'm going in the negative direction, if I go negative 4 pi over 4, I just went half of a circle, and negative 5 pi over 4 is going to be in this second quadrant here. So I am on the top half of the circle, so at least I'm on the right side of the circle. However, I am not in the correct domain because I need to be between 0 and 3.14. So let's go ahead and put in negative 5 pi over 4 divided by 4. And you'll see that I'm at negative 3.9. So that's definitely not within 0 to 3.14. But I can use coterminal angles to get there. And the way I can do that is I can add multiples or subtract multiples of 2 pi to get angles that are pointing in the same direction as this negative 5 pi over 4. And in the calculator, I can do that pretty easily just by doing this. I can put the fraction in there without the pi and then just add multiples or subtract multiples of 2. So if I go in here and I start with just negative 5 over 4 like this, and then I can just add 2 until I get a positive number. And it only took me one time. So I have 0.75, and I can use math, enter, to convert that back to a fraction. So negative 5 pi over 4 is coterminal with 3 pi over 4. 3 pi over 4. And we know 3 pi over 4 is in this top half. Let's make sure it's between 0 and 3.14, which I already know that it is, but just for checking here, if I do 3 second pi over 4, notice it's about 2.35, so that's good. So we're good. So 3 pi over 4 is in our domain of the inverse cosine function. So these two functions will cancel each other out, and we're just left with 3 pi over 4 for our answer. Now let's do one that's a little bit harder and that we're going to have to do an actual extra couple of steps here. Let's look at the inverse cosine of the cosine of negative 9 pi over 4 and see what extra additional stuff we have to do in order to solve this one. All right, so first of all, let's see if we can kind of figure out what quadrant we're going to be in for this. So if I start at 0 and I go negative 4 pi over 4, I'm pointing in the left direction here. If I go negative 8 pi over 4, I'm pointing back in the right direction. So negative 9 pi over 4 is going to put me in the fourth quadrant there. So not only am I not in my correct interval there, I am not even in the correct two quadrants. I'm in the fourth quadrant down there. So we need to do some work on this one. So I'm going to go back to my calculator here. I'm going to first put this in standard position by adding multiples of 2 pi until I get it to a positive angle here. So I'm going to start with negative 9 over 4. Oops, negative 9 over 4. And then just add 2. Still not positive, so I'll do that one more time. There it's positive. Now I'll go to math, frac, enter, and convert that to 7 over 4. So that is equivalent, or it's coterminal, to 7 pi over 4. So it's not the same angle, but it's pointing in the same direction as 7 pi over 4. So it's going to give me the same cosine value when I evaluate it. But as we can see, it's 7 pi over 4 is in the wrong quadrant. It is not in the upper half. So we can't evaluate that inverse cosine function yet. And if we also put in 7 pi over 4, we can see that that is 5.5, which is not inside our 0 to 3.14 domain. So no good. So how do we evaluate it? Well, if we notice on this unit circle here, if we look at, for example, 11 pi over 6, if we were to reflect this across the x-axis, we get 11 pi over 6. And if we look at both of those x values, they're the same thing. If we do that for all of these angles, if we reflect all of these angles across the x-axis, all of those x values are going to end up being the same, right? 5 pi over 4's x value is the same as 3 pi over 4's x value. 7 pi over 6's x value is the same as 5 pi over 6's x value, right? So if we have some method in order to reflect these angles up across the x-axis or down across the x-axis, then we can use a different angle to get the same x value once we evaluate this cosine function. So that's what we're going to do, and we do have a method. It's a pretty easy method. For cosine, all we have to do is take this angle and subtract it from 2 pi. And in the calculator, we can just do it without the pi, so I can just do 2 minus 7 over 4. And I get 0.25, turn that into a fraction, and that's 1 over 4 or pi over 4. So reflected across the x-axis, and if that wasn't in my, if that was not in standard position, I could then just add or subtract 2 pi to get into standard position. But luckily that was. So this reflected up here is pi over 4. So now I use pi over 4. So since this gives us the same x value as this, and we can verify that, but it works for anything that, even angles that aren't on our unit circle. So if we were to have like 9 pi over 17, we could still use this subtracting from 2 pi in order to find another angle that worked. So it doesn't just work for the ones on our unit circle, but now we just reflected it up here. So now we have everything we need. So the inverse cosine of the cosine of negative 9 pi over 4 is equal to pi over 4. And we are done. All right, if you have any questions, let me know, and I hope you have a great rest of your week. Thanks.